So, hello, good morning. My name is Zuila Wanghon. I am a master's student at Federal University of Santa Catarina, and today I will present my study. The blooming artefact reduction filter reduces implant dimensional distortion. Firstly, it is important to say that this study has no conflicts of interest. Cone beam computed tomography provides 2D images at lower radiation dose and could be applied for peri-implant bone evaluation. However, the appearance of tomographic artifacts compromise the evaluation of high-density objects and prevent their application. They are usually observed around dental implants and could mask osseointegration, bone defects, and peri-implant radiolucence. These artifacts can produce volumetric distortion, and this distortion can impair early detection of implant failure. In this image, we can see some tomographic artifacts present in dental implants tomographs. So to improve the final quality of the image, most of cone beam computed tomography scanners provides image post-processing algorithms called metallic artifact reduction filter. Recently, softwares have been improved this condition. A good example of this is the EVOLT-X, which offers the blooming artifact reduction filter, allowing the adjustment of brightness and contrast. The biofilter can reduce artifacts through tomographics, facilitating that analysis. So the aim of this study was to evaluate the influence of the biofilter on implant dimensions of cone beam computed tomography images, compare implants of different materials and manufacturing process. This in vitro experimental study has a randomized and blind design. So 6 types of implants were selected from 5 different brands and 4 different materials: titanium, titanium with zirconia, and titanium with aluminum and vanadium. And from 2 types of manufacturing process, milled or printed, which only the plenum was the printed one. To acquire a reference dimension was used the stereo microscope, and the study factors were measured by the implant length, diameter, and distance between the trees. The different dimensions was measured using the ImageJ software. 5 bovine ribs were cut and divided into 50 centimeter blocks. Only cuts between 10 to 50 millimeters were selected. To resemble the human jaw, we chose similar blocks with similar amounts of cortical and medullary bone. The drilling protocol of each type of implant was performed, and 6 images were taken, 30 for each type of scanner, eye catch or carry stream. In this image, we can see that the bone was held in position by a silicone index in the tomography. The images were exported in DICOM format and blindly analyzed by 2 different radiologists. The statistical analyses were made with repeated measures ANOVA, both erroneous corrections, and 2-way factorial ANOVA. In table 2, we can see good to excellent reliability between the 2 radiologists for all the measurements and for both scanners, with the interclass correlation coefficient vary from 0.8 to 0.95. In table 3, we can see the mean of implant measurements according to the use of the biofilter on each type of implant and each tomographic equipment. And we can see that several implants showing no dimensional distortion, regardless of the biofilter. And a dimensional distortion in the half of the measurements of eye catch images and in 44% of carrier stream images, regardless of the biofilter. And besides that, it's possible to see a significant improvement in the length and diameter of ceramic implants using the biofilter. And this can be explained because the higher the atomic number, the higher the radial opacity, the higher the tomographic artifacts. And ceramic implants made from zirconia presents higher atomic number than titanium. So the use of the biofilter can be more efficient in this type of implants. In this image, we can say that the biofilter presents greater accuracy in measuring dimension, because in the first image we can see the implants without the biofilter and the second one with the biofilter. And the second presents better visualization and fewer tomographic artifacts. In table 4, we can see that the titanium zirconium implants present higher distortion than titanium and zirconium. And in table 5, we can see that the printed implants present fewer distortion than milled. And this can be explained because the milling process produces more dense implants and higher tomographic artifacts. So in conclusion, we can say that the biofilter has the potential to improve the implant's dimensional analysis, although the results may change considering implant's material and manufacturing process. Thank you so much for your attention.